Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 4, Lesson 3, and we're going to focus on rectangles. So you've been studying rectangles for a long time, probably since preschool or maybe even before. The main thing that you need to know is a rectangle is a parallelogram with 4 right angles. A parallelogram with 4 right angles. So actually, if you saw a picture that looks like this, 4 sides and 4 right angles, that would be enough information to know it's a rectangle. So what makes a rectangle different from a parallelogram? Well, definitely the 4 right angles. So let's list out the properties. So rectangles have 4 right angles. The other thing that makes them different from any old parallelogram is the diagonals are congruent in a rectangle. Diagonals are congruent. So imagine the diagonals. They go from one corner to the opposite corner. That diagonal that I just drew in red, and then this other diagonal that I'm drawing in red, those two diagonals will be the same length in a rectangle, but they will not be congruent in a parallelogram. But then, after that, after the 4 right angles and the congruent diagonals, all the rest of their properties are very similar to parallelograms. For instance, in a rectangle, opposite sides are parallel and congruent. Opposite sides are parallel and congruent. Also, opposite angles are congruent, just like in a parallelogram. Consecutive angles are supplementary. Which means 2 angles right in a row will add up to 180. And then finally, the last property is the diagonals bisect each other. Diagonals bisect each other. So they have all the same properties of the parallelogram plus 4 right angles and congruent diagonals. Here's a quick one, number 1. A rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet, so let's label that, from here to here is 12 feet from J to K, and from L to N is 6.5 feet, so this part down here is 6.5 feet, find KM. So I'm going to highlight this. KM is this bar right here, this brace. We want to figure out how long that is. Well, it should be the same length as JL because diagonals in a rectangle, and this is rectangular, diagonals in a rectangle are congruent and they bisect each other. And so this, and this, actually all 4 of those end up being the same length. So if L to N is 6.5, then J to N is also 6.5 feet. So 6.5 plus 6.5 is 13 feet. And if J to L is 13 feet, then K to M is also 13 feet. Quadrilateral EFGH is a rectangle. So they're telling us this. If the measure of angle FGE, so let's find FGE. Here it is up here. If that is 6x minus 5, and the measure of angle HFE, so HFE, so that is this angle down here, and that is 4x minus 5, then find x. Okay, so here's what we're going to think about. Think about this red triangle, or actually I'll make it blue. Think about this blue triangle over here. So one of the things we know, if this is a rectangle, then this and this are the same length. Actually, all four of them, right? These are also the same length. But if you think about that blue triangle, it's an isosceles triangle. It has two sides that are congruent. And if it has two sides that are congruent, then it also has two angles that are congruent. Go across from those congruent sides, and you're going to figure out the 6x minus 5 at angle G is also going to be congruent over here. So now think about this corner down at angle F. This whole corner is 90 degrees if it's a rectangle. And so the 6x minus 5 plus the 4x minus 5, those added together should equal 90 degrees. Just remember, when you have an isosceles triangle like this, the two angles across from them are congruent. So that's how we knew that this other angle, angle GFJ, was also 6x minus 5. All right, now we can start solving for x. So we have 10x minus 10 equals 90. Add your 10. 10x equals 100. Divide by 10. And x equals 10. And yay, it's one of our choices. That's always a good thing. Max is building a swimming pool in his backyard. He measures the lengths and the width of the pool so opposite sides are parallel. He also measures the diagonals of the pool to make sure they are congruent. How does he know that the measure of each corner is 90 degrees? Is it because A, opposite sides are parallel, that it must be a rectangle? B, opposite sides are congruent, so it must be a rectangle? Or C, since the diagonals of the quadrilateral are congruent, it must be a rectangle? So what actually makes it the rectangle? Well, just because it has opposite sides does not mean it's opposite sides parallel does not mean it's a rectangle. That could be any kind of parallelogram, so that does not make it a rectangle. Just because opposite sides are congruent, again, that could be just any old parallelogram leaning. It does not mean that it's a rectangle. But part C, if the diagonals are congruent, if this diagonal from R to S is the same as this diagonal from S to U, then yes, it has to be a rectangle. So I'm going to tell you a quick story. Our family has a cabin, and one of our neighbors, he is about 84 years old at the time, Marlon, was going to build a garage. And he was out there putting 2x4s down so that the cement truck could come and pour the floor. And he's like, Jen, come over here. And Marlon's a really handy guy. And so what he did is he had me hold one end of a string. So let's pretend this is his floor that he was putting 2x4s here and here and here and here so that the cement truck could pour the cement in the middle. He had me stand at one corner, and then he went and stood across from me at the other corner, and we stretched a string across. Then he went up here and he stood here. And I went down here and stood here, and we stretched the string again. And what he was looking for is, was the string exactly the same length from diagonal to diagonal in both spots? Well, it turned out that one of them was about 2 inches shorter, and so he knew his corners weren't perfectly square. So then he went on and adjusted his corners and whatnot. And so it was pretty cool. He actually used this idea in real life as he was getting ready for cement to get poured. Pretty cool. Quadrilateral WXYZ has these vertices. Determine whether WXYZ is a rectangle using the distance formula. Well, first off, remember the distance formula. Distance is that big square root x2 minus x1 squared plus y2 minus y1 squared. So we have to somehow use this distance formula and prove that this is a rectangle. Okay, I'm going to start by drawing a quick little sketch. So I'm just going to make a little graph like so. And now I'm going to plot some points. So W is at -2, 1. So W is at -2, 1. And X is at -1, 3. and y is at 3, 1, and z is at 2, negative 1. Then I'm going to connect them. And it does look kind of like it could be a rectangle. But I'm supposed to determine if it is for sure by using the distance formula. And so what I'm going to do now is I'm going to do a bunch of distance formulas. But I'm going to start by doing xz. xz is one of the diagonals. And so imagine this distance across here. I'm going to find xz first, and then I'm going to find wy and see if the diagonals are congruent. That's going to be a good start, because if they're not, I could stop right there. So for xz, I'm going to make my big square root, and I'm going to do, let's see here, x2 minus x1. So I'm just going to do 2 minus negative 1 squared. So if you can see, I started with this 2 and this negative 1. And then I'm going to do the negative 1 and the 3. So plus negative 1 minus 3 squared. This becomes a plus. And so I wind up with 3 squared plus negative 4 squared, which is 9 plus 16, which is 25, which is 5. So that diagonal has a length of 5. Now I'm going to do the other diagonal, which is w to y. So it's across here. So wy, make my big square root, and I'm going to do 3 minus negative 2 squared. So I have this 3, this negative 2. And then I'm going to go plus 1 minus 1 squared. This becomes a plus. So I have 5 squared plus 0 squared, which is root 25, which is 5. Haha! The diagonals were the same length, so that's a good start. The diagonals are the same length. I just need to figure out if the sides are parallel. As long as the sides are parallel or the same distance, the same length, if opposite sides are congruent or parallel, then this is definitely a rectangle. And so the other thing I should probably check quick is the distance from x to y, the distance from y to z, the distance from w to z, and the distance from w to x. Holy smokes, we're going to have to do 4 distance formulas. I'm going to pause the video here. You do that too, and then let's check if we get the same answers afterwards. Wow, that's a lot of distance formula. But you can see that my opposite sides were congruent. I had 2 sides with length of root 20, and then I had 2 sides with length of root 5. So not only were opposite sides congruent, which makes it a parallelogram, but remember our first 2 distance formulas proved that the diagonals were also congruent. So yes, this is a rectangle. Okay, these last 2 questions are review from 4.1 and 4.2. Will you please pause the video and try this example? So we need to find R, S, and T if WXYZ is a parallelogram. Well, let's start with R. So I see 4R here. If this is a parallelogram, opposite sides are congruent. So the 4R will equal the 18. Divide by 4. And R is 4.5. Next, let's try to find S. So one of the things I notice is right here is 8S, right here is 7S plus 3. If this is a parallelogram, that diagonal gets bisected, which means the 8S should be equal to the 7S plus 3. Minus 7S, S equals 3. And then lastly, let's find the T. So I see the T right here, 2T, and then I see this down here. Since this is a parallelogram, the sides are parallel to each other, and so these 2 angles, the 2T and the 18-degree angle, will be alternate interior angles, and they will be congruent to each other. So divide by 2, T equals 9. Great, please pause the video and try this last example. So what is the sum of the measures of an interior angle of a 16-gon? For this, you're going to use the formula n minus 2 times 180. So if we have a 16-gon, we do 16 minus 2 times 180, which is 14 times 180. And 14 times 180 is 2,520 degrees. So that is what all of the angles added together in a 16-gon would add up to. All right, thanks guys. It's time for you to practice this stuff. So will you please try Unit 4, Practice 3. Submit it to me on Schoology when you're done. If you have questions, please let me know. Have a great day.